Hey, this is Ayushi from Edureka. So first of all, I would like to welcome and thanks all the attendees for joining the session. So this session is all about Java classes. So without any further ado, let's move on and see the agenda for today. So we'll start off the session by first discussing what a class is and what are the different components in a class. After that, we'll be learning about constructors and how they play a major role in a class. Moving on, we'll see the structure of a class where I'll be summarizing the above two concepts with a programmatical example. Next, we'll see another key concept in a class, that are objects, and how can you work with them. How can you create them, access them, and play around with objects. Towards the later half of the session, we'll be going through slightly advanced concepts where I'll be talking about multiple classes and object-oriented concepts such as inheritance, abstraction, encapsulation, and how can you work with them. So are we all clear with the agenda? Kindly give me a quick confirmation by writing down in the chat box so that I can proceed. Okay, so I'm getting confirmations. So Tyler says looks fine. Anamika says a yes. Samir says go ahead. Alright, so we are good to go. The first topic is getting an introduction to a class, or what is a class. So a class in Java is a blueprint which includes all your data that is present around you. Now if I have to give an idea of what a class is, let's see this real life example of a car that we see in day-to-day life. Now have you ever thought of how a car is created? At first you need a design wherein you can put all the functionalities to it. So for example, you must know where a tire should be or a steering wheel is placed in a car. So all these things needs a structure, and that exactly a class is. So once you design a structure, it will ease your task as you don't have to repeat the same steps again and again. That is how it minimizes this redundancy. But how can you do that? Here comes the concept of objects, because a class helps you understand on how an object would be looking. So you might be wondering what an object is. So don't worry guys, we'll be learning the whole concept of objects in a while. But here to give you a quick overview of an object basically is everything you see around. For example, dog is an object of animal class, or you can say I am an object of human class. Similarly, they can be different objects to the same car class. Now moving towards the syntax of a class, or how can you define a class in a Java code. So a class logically groups our data and functions together. So if we go in technical terms, these are called as variables and methods. So we learn about these things in detail, but if I have to relate to the same example here, my variable here are color, model, and price. So variable is nothing but an attribute of a class. Then we talk about method. They are just the functionality of a given class. Here the main function to make a car move is speed. So I declare a method speedup. Similarly, you need to gear up whenever you speed up a car. So if you don't do, you'll end up killing up your engine. Therefore, these things are really important to function a class. So you guys have seen the structure of a class with respect to car. So let me just show in my IDE on how a class looks like. So this is my employee class where I have some variables like ID, name, and some more. So here these are all my methods. So this is just a simple understanding. Don't worry if you're not clear with anything. We'll be talking about each one of things that are declared here individually. So now let's go in detail of what a variable is. So a variable is used to store a data value. So if I talk about the same example of a car in my previous slide, I took the variable as color, model, and price. So every car must has a color, right? But the values can be different. My car can be black, yours can be red. Or if we talk about model, I may be driving an Audi A4, you may be driving A6. Similarly, I may be paying a different price, you may be paying different. So all these are considered to be a variable where the values are changing with their own requirements. Now coming back to the slide, a member variable is a variable that belongs to a specific class. So these memory variables are classified into three types: local, instance, and a class variable. So let's see what exactly they are and how they are used. So a local variable is a variable that can be accessed within a function. So in these variables, the scope remains still a function. So just to remind you guys, a function is again a set of rules that you wish to operate with the different values. Next, instance variable. These variables are declared outside a method, constructor, or any block. So these variables are unique because these values are instance specific. Finally, when we talk about class variable, these variable doesn't need a separate memory allocation. It shares only one copy that is taken by everyone. So let us see how you can implement them practically. So this is my car class, which has some variable and methods to it. Now a local variable is a variable that is declared within a method. So I created a method called as display where I've passed an argument as m. Now my local variable is model here, which has a value m associated to it. And here I've just printed this value. Then second I have instance variable. Now these variables are declared outside any class, constructor or anything. So in this case, color is my instance variable, which has a value black to it. Third is the static variable, which has one copy, which is shared by all. So in my example, all cars are having 4 tires, right? So I have declared a static variable that is tire, which has a value 4. So I hope you guys are clear with different types of variable. Let's see how a variable is initialized in a method, or how can you create your own method and put in different functionalities to it. So as we discussed earlier, methods basically is a set of rules or operations that describes the behavior. So you might have a question, why are we not writing these set of rules in a program, or why do we need a separate function for this? So the answer here is to reduce redundancy. So if I have to take an example, let's say I have to add 2 numbers for a large data set. So one way of doing this is by writing the code multiple times. But you must be aware of the fact that a program follows top-down approach where a compiler executes the code from line 1 till the end. So here if you start writing your code, it will waste a lot of time and energy. So to avoid this, you can just create a method which has addition formula where the 2 numbers can be added ultimately. So this is how you can overcome the problem and use methods instead of writing it again and again. So Tyler asked me, how does methods affect the performance of a program? So as I just discussed, Tyler, methods are used to reduce the code redundancy, or you can just reduce the complexity in your program. Because the good part of a method here is you can send in different values to the same function. So don't be confused because the methods and functions are same. So I hope you got your answer now. Alright. So now let's jump off to the next topic, that is a constructor. So constructor is basically a special type of function which has the same name as that of a class. So you might be wondering why a constructor is used. Well, a constructor is used whenever an object is created. Or it won't be wrong in saying a constructor is automatically called. So here again you'll be thinking about objects, but don't worry, I'll be telling all about objects in the furthermore slides. But for now you have to keep in mind that these constructors doesn't have a return type. So let's see how these constructors are classified. Majorly, there are 2 types of constructor, a default constructor and a parameterized constructor. So let's know more about them. So default constructor is something that is created automatically when you don't create a constructor. So here you don't pass any argument to it. Also, it is further classified into 2 types, the one which is automatically created and the other is user defined. Whereas in a parameterized constructor is where you pass parameters to a constructor. It might be of any data type. It can be of int, string or anything. So now let's implement them practically. So here is my car class. So I'll create a default constructor. So as you must know, the constructor name is same as that of a class name. So here then I'll print this is my default constructor. Next, what happens if you don't pass any value to it? That is a case when compiler picks a default value. So first let me just delete the value of color, which is black. So let me print these both color and price. So since my color is of integer type, compiler picks up a value 0 and price is of string data type, so we'll take a null. When we talk about a parameterized constructor, again I have to pass parameters to it. So I'll pass string C and integer P, which refers to color and price. So I'll make a local variable that is color, which stores the value of C. Similarly, I create a local variable of price that stores the value of P. Now again I'll print that this is my parameterized constructor. And again, I have to print the color and price. So I'll just copy it from here and paste it here. So this is my default constructor where I haven't passed any parameters to it. And in this case, I have passed string and integer. So this is my parameterized constructor. So I hope you guys are clear with constructors. So now we have talked about methods and constructor. But let's say if you want to keep these methods something specific related to your card. Now how can you do it? Also you might be wondering, why are we using this public keyword always? So to understand that, let's talk about the next topic, that is an access specifier. Public is an access specifier. Similarly, we have three more: private, protected, and default. So I'll give you a simple understanding of what these are and why they're important and useful for us. So my first specifier is public. So public, as the name says, it is accessible from everywhere. So if you declare a class, method, or a variable as public, these can be accessed from any other class or package. Next, we have private modifier, which basically limits your scope. So here the scope remains within the function. Or if we talk about a class, the scope remains within one class only. So that is how you can differentiate between the two. Public is accessible to all, whereas private is completely private. Then it comes protected access modifier. Now in a protected modifier, the properties can only be accessed by the subclasses. And finally, there is a default modifier for which you don't have to write anything. It is basically taken by default where you can access the properties in the same class but not from a different package. So as we discussed in previous slide, let's look at that in a tabular manner so that you can get a complete understanding with respect to it. So here I've given a brief explanation to all of these modifiers. And if I connect, a public is accessible from anywhere. So you can access it within the same class, same package, subclass, and other packages as well. Then there is private modifier, which is accessible within the same class but not the same package, subclass, or other package, as the scope is limited for them. Similarly, there is protected, which is accessible from everywhere but not the other packages. And in the end, there comes a default, which is accessible from the same class and package but not from the other two. So I hope you guys are clear with access modifiers and how they are different with respect to classes and packages. So kindly give me a quick confirmation, guys. Okay, Tyler is saying looks good. Okay, so Samir is asking me a question. What do you mean by a package and subclass? Okay, Samir, so a package is basically a namespace that organizes a set of classes and interfaces. Now hang on, we'll be going through interfaces in the later session. Also, you asked me about subclass, right? So a subclass is a child class which inherits the property of a parent class. Now here again, the concept of inheritance pops in. So I'll be explaining both your interface and inheritance in some more minutes. So I hope now everyone is clear with it. Alright. So now we come to a structure of a class. So again, this is just a summarization of what we have learned till now. So here is my Java code that explains it all together. Now this is the name of the class, and I've talked about member variables and the different types. Then I've talked about constructors and how you can initialize them. Then we have also discussed about methods where you can put in all the functionalities. So you guys have seen the structure of a class with respect to card. So let me show you another example of a class student. So this is my student class, which has some variables like ID and name. Then I have my default constructor. Then I have my parameterized constructor. And here is my method, which displays the name and ID. And then there is main method, which basically executes all your code. So I hope you are clear with structure. So till now we know about variables, constructors, and methods. Or you can say how a class is designed. Basically, we have just completed a blueprint, but now comes the implementation stage, or how can you actually access these variables and methods that are present in a class. So to do that, we need another key concept that is known as objects. So an object basically is a child entity that has a state and a behavior. By state, what do we mean? It basically refers to a variable, and by behavior, it's your method. Now if we take the same example of a car, where this is just a blueprint, and this is actually an object of a car, where each state variable has a corresponding value to it. So where we see color, model, and price earlier, now we have seen objects that has a value. Say, color of my car is orange, or model has a value 1. Similarly, price has a corresponding value to it. Now we talk about functionalities or behavior that we have just seen earlier in a class is still present in my object. that is my car needs to speed up, and as it speeds up, it also needs to change its gear. So one thing that you must have noticed that the behavior that you set in a class is something commonly present to all the objects that you create, but the value of the state keeps changing from object to object. So now let's begin working with objects. So there are basically three stages for creating an object. You have your declaration, instantiation, and initialization. So this is basically a syntax of how you can create a new object. So you use a new keyword. Now you've already seen this, so let me go back and explain you what each part of syntax is for. So this is my class name, that is student, followed by the object name. Then there is this new keyword which basically allocates the memory for the object. So this new keyword is followed by a call to constructor. Let's say if you're not going to specify any value to that object, you can call a default constructor. So in my case, I've not seen any parameters to this. So I know it becomes my default constructor. Then there are three ways where you can initialize an object. So the first is by a constructor. So here, as you can see, I can use a default or a parameterized constructor to store a value to my object. So let me just go back to my previous code. So here, as you can see, I haven't passed any parameter to it. So this is basically my default constructor. And this is my another object, that is stu1, where I've passed the value of ID and name. So ID here is my 1 and the name of the student is Ayushi. Then there are methods. So as we've discussed how you can pass values to a method. So let's see how you can call them using an object. So here let me take an object, that is student, which has a method, say display. Now it has an ID as a parameter, so let me put an ID, say 2, and a name that can be. So this is how you can pass values to your method. Then the third way of initializing is calling by a reference variable. Now what it is? Till now what we have done is actually pass the value to a constructor or a method. But how about creating an object, or you can say a reference variable, to access them? Let's see again how it is done. So I'll take another object, say student1, where I'll put the values of ID, say 3. So here it is accessed using a dot variable. So let me just print it here, this student1.id. So let's run the program and see what it shows to you. So here, as you can see, the first object is my default constructor. So the values are 0 and null. So now why 0? Because the ID is of integer type, so the compiler takes the value 0. Similarly, for string, it takes null. Then we have created a parameterized constructor which says the value 1 and Ayushi. And that is printed. Then it is by a method which passes a student ID and student name. So here I have passed 2 and John, and that is printed. Then by reference variable, I have initialized an ID, that is 3, and this is printed. So now I hope everyone is clear with all these three methods to initialize an object. Okay, most of them says yes. So let me move forward. So now that you got an understanding on how to work with class or how to work with objects, now just take this to a higher level where we'll understand how to work with multiple classes. Now you may be wondering, why do we need these multiple classes? So no Java code is written with just a single class. And when you're looking at real-time project, you may be having thousands of classes as part of your code. So what we'll be doing today, we'll work with 2 classes. So this is just a reference to understand where I have created 2 classes which contains a constructor and a method in both of them. So let us see in my IDE where you can create 2 separate classes and perform operations on it. So now to understand this, I have to create one class. So new, then class. Let's say I name it as A. Created it. I have to create another class, so I'll go to class. Then I name it as B. Put in the main function. Just finish it. So in my A class, first of all, I need to define my constructor. So let me say sys.out, which says this is my. Then I'll create a method, which again says that this is the method of class A. Similarly, in my class B, I'll create a constructor and a method. So I'll just copy it from here. And I'll just change that this is the constructor of class B. And this is the method of class B. Change that this is the constructor. And the method is B method. Then say I have my main function in class A. With first of all, I will create an object of class A. So that is A, let's say object of A, then new, which basically allocates the memory, and then A. Then I just create an object of B class, say class name, that is B, then object of B class, and B. Then suppose I have to access the methods of class B. Then I'll just write object B dot B method, and I'll just call them. So let me just go on and implement this. So they'll ask me that you have to implement A and B, so I'll say yes. So the first thing that I have called is the constructor of class A, that is, this is a constructor of class A. Then I've called a constructor of class B, this is the constructor of class B. Then again I've called the method of class B, which says this is the method of class B. So I hope you guys are clear with multiple classes and how do they work. So again, the output that I have just shown in my IDE. So now let us focus on OOPS concepts, where I'll be talking about inheritance, abstraction, encapsulation, and how can you achieve them using a class in Java. So the very first topic is inheritance. So all of you must be familiar with inheritance. So it basically inherits the properties which can be further used. So here if you see in Java, a class acquires the property of another. Now whose properties are inherited? So there we have two classes where a child class inherits the property of a base class, or you can say a parent class. So a class whose properties are inherited are known as base class, whereas class which inherits those properties are known as child class, or you can say derived class or subclass. So these are just the different names to call a class. Then we have several types of inheritance such as single, multiple, hierarchical, and hybrid. So let's learn about them one by one. So my first type of inheritance is single inheritance. So this is the easiest type where a single child inherits the property of a parent class. Now how can you inherit them? So in Java we use this keyword as extend, which is used for inheriting the properties of other. So this is my syntax where I have my class A and my other class B is inheriting the same class A using an extend keyword. Then we have multi-level inheritance where there can be different classes that inherits the property. So for example, your parents would have inherited some properties from their parents. So in turn, you also inherit some of them from your parent, right? So if we look here, class A is my parent class and B is a child class, which is inheriting the properties of A. Now B can also be my parent class, which has a child class C, and that is inheriting the property of B. So if you see the syntax here, class B extends A and similarly class C inherits B. Moving on, then there is hierarchical. So in this, one class is inherited by many subclasses. So how many of you have siblings? So I have a sibling and we both share a lot of things that is similar, and that exactly is hierarchical. So if you look here, class B and class C are siblings, or you can say child classes which are inheriting the properties of class A. And again, if you see the syntax, class B extends A, where class C also extends class A. So we have discussed three major types that we've seen in Java. So before I go ahead, does anyone has knowledge of C++? So Tyler is saying yes. So is Bibek. Okay, so Samir asked me, is it important to have knowledge of that? Okay, Samir, it is not that important, but I can just relate to the topic that we are about to learn. Okay, so Anamika also says a yes. Since most of them are saying yes, so guys, you must have seen many types of inheritance in C++. Now guess why you cannot find all these types in Java? Or what is the challenge that Java is not supporting these types? So the main objective of Java is to make it simple or easy for everyone. So it removes all the complexities such as multiple inheritance, which I hated a lot. So let me go to another type of inheritance, that is hybrid. Now if you have learned about multiple inheritance, you might be having many doubts. But to help you here with respect to these inheritance, hybrid is a combination of single and multiple inheritance. So in Java, as you know, multiple inheritance is not supported. As you must be aware of diamond problem, where the two subclasses were inheriting the same properties of the parent class, which has leading back to ambiguity, and that is why Java doesn't support it. But here you can achieve this hybrid inheritance using an interface. Now interface play a major role here. So we'll be learning about interface in a while, where I'll be explaining what exactly is interfaces and how it is useful to achieve this type of inheritance. Then my next object-oriented concept is encapsulation. So encapsulation in Java is a mechanism of wrapping up the data and code together as a single unit. So here if you see methods, variable, all are binded together in a single class. So in encapsulation, it also provides the functionality where the variables of a class can be hidden from another class, and which can be accessed only through the members of the current class. But now the question is, how can you do that? So to achieve encapsulation, there are two methods. The first is where you can declare the variables of a class as private. So you've already seen this where you can declare your variable as private. Well, the second method is where you can provide setter and getter methods to modify and see the values of the variables. So let's see the second method where we can create a getter and setter method to access these values. So here if you see the code, I've created a class employee. Now this class has a private variable that is name. So this is the first case where we have used the private access modifier. Then we have created a getter method which takes the name of the employee. Then we set that name in a setter method. Therefore, any class that wants to access the variable should access them through these getters and setters. So let me go to my IDE and show you how you can create these setter and getter methods. So here I'll create a class, say employees, and I'll include the main function and finish. Now let's say I have to create a private variable. Let's say it's the name of the employee. Now you don't have to manually write these getter and setter methods. You just have to right click, go to source, and here you have an option of generate getter and setters. You have to click on name, that is my variable, and click OK. So this is my getter method which has a name, say get name, which basically takes the name of the employee, and in my set name method it just sets the name. So by here you guys must be clear on how these methods work and how encapsulation helps you to bind the code together. So if you have any doubts related to any of the concepts that I've just explained, you can ask them by writing down in the chat box so that I can explain them again. So Vivek is saying all clear, Anamika says perfect, Samir says go ahead. Alright guys. Okay, so now let's move on to another concept, that is abstraction. Now abstraction is basically the quality of dealing with ideas rather than events. So for example, when you consider the case of this car, here the mechanic is repairing a certain function that is present in a car. But the user, or you can say driver, doesn't want to know about these things. So he just wants that his car gets repaired fast. So in these types, you can basically segregate the implementation and show the other person what he actually wants to see. So here, how can you achieve this? You can achieve this by using an abstract class and interface. So let us discuss what they are. So an abstract class is a class which has the abstract keyword to it. So here in these classes, you cannot instantiate or you cannot create an object to them. So it may or may not contain abstract methods. Now what exactly an abstract method is? So an abstract method is a method without a body. So here if you can see, this is my syntax where abstract is my keyword followed by the name of the class. So also you have to keep in mind that if a class has at least one abstract method, then the class must be declared as abstract. Again, if the class is declared abstract, it cannot be instantiated. Okay, so Vivek asked me a question. How can you use an abstract class then? Okay, that's a great question, Vivek. So to use an abstract class, you basically have to inherit it from another class, or you can say you have to provide implementations to the abstract methods there itself. So if you relate, we have done this before in multiple classes where I've explained you the working of different class in separate class files. So is it relatable, Vivek? Or do you want me to repeat that slide again? Okay, so he says he got it. Alright, that's great. Now coming to my last topic, that is interface. So interface in Java is a blueprint of a class. Or you can say it is a collection of abstract methods, constant, and everything else around. So in an interface, each method is public and abstract by default. Also, it does not contain any constructor. So let us see how you can declare an interface. Here if you can see, I have created an interface as car. So let's say we have three methods here, change gear, speed up, and apply brakes. So all my car have these functionalities, right? But how they work, they're going to be different. Let's say you're working with a manual car. Then you have to increment the gear one by one. But if you're working with the automatic car, that time your system decides how to change gear. Therefore, not all my subclasses may have the same logic written for change gear. Same case is for speed up. Now let's say when you press your accelerator, it speed up at the rate of 10 or 15 km per hour. And suppose I'm driving in supercar where it increments by 30 or 50 km per hour. So again the logic varies. Similarly, it's for apply brakes where I may be having powerful brakes and you may not have the same. So what we're doing here, since all the functionalities are common with all my subclasses, so I'll create an interface where all these functions are present, and then I'll be creating a child class that implements this interface. But the logic would be defined only there. So the functions will be present as part of that, but the logic varies. But how can you implement an interface? So let me show you in practical where I'll be providing all the functionalities to your methods. So here I have to create an interface, say my interface name is parent car. Here I have to write my methods that we just discussed, that are change gear, speed up and apply brake. So let me just write it down for you. So now we're done with writing these three methods. So now let me create another subclass, say an Audi class, which basically implements my interface, that is a parent car. So I'll create a class here, say Audi, which has a main function. I'm so sorry. I'll rename this as Audi. And this is done. So first of all, I have to implement my interface, that is parent car. So it is done by using an keyword, that is implement, followed by the name of my interface, that is a parent car. Now I have to declare some variables to it, say speed and gear. Now I'll add these methods that we have just declared in my interface. So I'll write my first method, that is change gear. I'm so sorry. Yeah, now it is fine. Then I'll write my another method, that is speed up. Now here I am putting some functionalities to these methods. So let us see what happens after we add on these functionalities. Here I am incrementing my speed. Then I'll write my third method, that is apply brakes, where I'll pass an argument as decrement and I'll decrement my speed by this variable. So we're done with these three methods. Now let me create an object for this. Say Audi A6 is equals to new Audi. Then I have to call my function using this object, where I'll give some value to it, say suppose 50. Okay, 1 minute. Okay, now it looks fine. Okay, so let me create one more method which displays all these values. Say void So in this method, I have just printed all the states which says my speed, gear. So now let me call this method by an object name. So here it says print states. Then I'll call another method, say change gear, and let me put value 4. And again I have to print, and say I have to call another method, say, and in the end we have just printed the states. So now let us run this program and see the output. So here my speed is 50, gear is 1, Then for my second method, speed is 50 again and gear is 4. So I hope you guys are clear with how an interface works. So here I can give you another example where I create another class, say BMW. So I'll just create a new class for you. So here I just copy paste my code. Alright, so now you must be wondering why I've created this BMW class. So here in my all methods, I'll just change the functionalities and let us see what does it affect in my interface. So in my first method, I'll just change the value. I'll just increment the gear value by 1. Then in my speed up function, I'll just increment my speed by the multiple of 2. And similarly, I'll increment here by 4. So let us run now. So here again you see different values to the same function by implementing the same interface, that is my parent card. So this is the magic of an interface. So this brings us to the end of the session. So let me give you a quick summary of what we have learned till now. At first we saw Java classes where I took a real life example of a car. Then we have learned about constructor and their different types. Later we talked about access modifiers and how they are used differently with respect to a class and a package. Then we saw a structure of a class where I summarized the previous topic with a programmatical example. Then we talked about objects and how can you work with them. And finally we talked about OOPS concept and how you can implement them in Java. So I hope you guys find this session useful. So any kinds of question or doubts you're facing in any of the concept that I've talked about in this session, you can just write it down in your chat box or probably connect with me in my next session. So any question guys? Alright, so Tyler says no thank you. Vivek says it was a nice session. Alright, so thank you so much guys for attending this session. Also this video will be uploaded to your LMS, and if you have any doubt you can reach out to our support which is 24/7 available. So by this I hope you guys had a better understanding of Java classes. Well, thank you everyone. Have a great day. Goodbye.
I hope you enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries and we will reply to them at the earliest. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning!